Okay, so now we have three formulas. We have x equals x0 plus velocity times time. This is the final position or displacement with the constant velocity formula. This is similar to the next formula, final velocity with constant acceleration formula. How do I find my final velocity if I know what the constant acceleration is? And then we said, how do I find my final position if I have a constant acceleration and I know my initial and final velocities? Okay, so now what if I don't know my final velocity? Okay, what if I don't know my final velocity? So here's what I'm going to want you to write down underneath this. What if I don't know final velocity? So what I want you to write down is that you do know, okay, you do know a formula that puts final velocity in terms of initial velocity and acceleration in time. Okay, I know this formula, so maybe I could substitute this in for this. Okay, so what we're going to say is we know V equals V0 plus AT. So substitute this in for final velocity or V in the displacement with constant acceleration formula. And think about this as you're writing it out. Substitute this in for final velocity in the displacement with constant acceleration formula. Now, recognize that I'm not ever going to ask you to derive these equations or come up with these equations on your own. I'm putting this in here for the more mathy of you, those of you that really want to know how we got these equations. It would be bad of me to just say, here, these are the equations you need, without me showing you how I got those equations. I need you to see how I got these equations. I don't need you to be able to repeat it back to me. Although, if you're interested, maybe in some extra credit sometime, you could show me that you know how we got these or how we derived these, and I would give you some extra credit for that. Okay, so if you could go through the same process we're going through here without any resources, I would give you some extra credit. Okay, so let's do that then. Let's say we know that x equals x0 plus 1/2 V0 plus V times T. And now I'm going to substitute in this for this. And this is going to give me x equals x0 plus 1/2 V0 plus v0 plus at times t. Okay, now I can simplify this. I've got two v0s. Okay, so I can say that x equals x0 plus 1/2 times 2 v0 plus at times t. Okay, now for this first term here, 1/2 is going to cancel out the 2. So I'm just going to end up multiplying v0 times time, right? So now I'm going to get x equals x0 plus v0 times time. Then if I multiply the 1/2 times at and multiply that times t, then I'm going to get 1/2 times at squared. Okay, so 1/2 times at times t is going to give me 1/2 at squared. So this is going to be my next formula, and we're going to call this displacement or final position, whichever you prefer. Displacement with constant acceleration. Okay, and you're going, wait a minute, Marshall, we just called the other one displacement with constant acceleration. How are we going to make this one different? So we're going to just say displacement with constant acceleration, no final velocity. Because I don't have a final velocity, right? And so if I have the acceleration but no final velocity, I can use this formula. And we'll use this formula a lot, okay? Especially because a lot of times x0 is going to equal 0, and v0 times time, v0, my initial velocity, will be 0. So this term drops out. And a different form of this might just be x equals 1/2 plus at squared, or plus 1, x equals 1/2 at squared. Okay, you may have seen that in your algebra classes. In any case, this is our next formula. So let's go ahead and we're going to create one last formula after this one.